Welcome back everyone. This is Dr. Harshavardhan Hilli, Assistant Professor, Department of Genetics and Plant Breeding, PGCA, RPCA, PUSA. So in the previous lecture, I had already discussed about the quantification of the DNA, extraction of the DNA, and some of the basic aspects also. So in this video, in this lecture, we are going to talk about the Agarose Gel Preparation and how to run the gel as well. So what we need to do here, if you want to go for DNA quantification, you need to prepare 1% Agarose gel. So for that you need to keep the TE buffer ready. Okay, so you need to prepare this TE buffer. That means you are going to weigh 0.121 gram of space and you are going to weigh 0.037 gram of EDTA in 100 ml, and then you are going to adjust the pH to 8. So you are keeping this particular buffer ready. So once you are keeping it ready, then what you need to do, you need to take 1 gram of this particular agarose. That means you are going to weigh 1 gram of agarose powder, and then you are going to put in the conical flask, and then you are going to add 100 ml of this tea buffer. Okay, so once you are doing this, then you are going to heat this particular mixture. Okay, that means you are going to keep that particular conical flask with the agarose inside this particular oven or whatever it is. So until this particular agarose is completely dissolved. Okay, the solution should be very much clear. It should be very much transparent also. So once the agarose is very much well dissolved in this particular hot air oven, so what you need to do, you need to let it cool down. Okay, so for few minutes. So once the your solution is cooled down, then you need to add the staining dye. So probably we are going to use the ETBR. So 2 to 3 drops or 3 to 4 drops is sufficient in order to stain that particular gel. Okay, so once it is done, then what you need to do, so you need to like pour that particular gel, okay, whatever the gel material that you have prepared in this conical flask along with this ETBR staining dye, you need to like pour in this particular gel casting tray, and then you need to allow it for solidification. So solidification, it takes around 40 to 60 minutes. And once the solidification is done, then what you are going to do, you are going to use this particular gel for like loading the DNA sample. We will just go through it using this particular flow chart. You can just see here, these are the combs. That means white ones are the combs which are used to create the wells. Okay, so the wells should be there in order to load the sample. For that you need to use this combs, and these are the gel trays. So what you are doing, you are going to prepare the gel you have prepared, and then you are going to pour the gel in the casting tray. So you are going to pour it, and you are going to leave it for solidification. That means you are going to pour this one, and you are going to place these particular combs inside this particular tray, and then you are going to allow it for solidification. Once the solidification is done, you can just remove out the comb. You can just see here, these combs will be removed out once the solidification is done, so that the wells are created here. Okay, so this is the particular picture. You can just see here, it is a gel with the wells clearly visible. So you are going to load the samples here. Okay, so what we are going to do is, we are going to load the sample. You can just see here, for that you need to load the samples individually in each individual wells. For that you need to take the DNA and along with the loading dye. Okay, say for example, you are going to take 5 microliter of the DNA. That means 3 microliter of dye is sufficient for that. Okay, so you need to add like this. So you should be very much careful while loading this particular sample. So you should be clearly adding the samples inside that well itself. Okay, so once you are loading it, then you are going to connect this electrophoresis unit. You are going to give the power supply. You are going to switch on this electrophoresis unit at 80 to 100 volt, and you are going to keep it around 50 ampere current. Once you are going to do this one, then you are going to run this particular gel for 40 minutes, 50 minutes or 1 hour. So if you are going to keep it for 1.5 hours also, then there is no problem. What we need to do, once the gel is run for 1 hour or so, you are going to take out that particular gel from this electrophoresis unit, and you are going to observe under this UV transilluminator. So once you are going to observe under this UV transilluminator, then you are going to see your particular DNA samples. It is run at this particular level. Okay, so these are the wells, and you have loaded the sample, and after giving the voltage in this electrophoresis unit, the product has been run. Okay, so what happens with this, you can easily come to know the band of that particular DNA, how much intensity is this, how much intensity of the DNA like a DNA band is observed, that you can see. So based on that intensity of the bands, you can easily judge the quantity of the DNA. So this is for quantification. Similarly, you can use the same methodology in order to prepare the gel. Okay, Okay, for the PCR product, once you are amplifying the product, once you are applying the primers and running the sample, you can also use the same methodology. But the thing is, here we are going to use 1% gel for DNA quantification. That means very thin gel. Okay, but for a PCR product, you are going to prepare minimum 3% gel. So once you are preparing 3% gel, even you will be allowing you will be putting the DNA samples and the PCR products, okay, whatever it is, inside the inside the like gel wells. Okay, so you are going to run it, and same procedure you are going to follow in order to observe the sample. So hope I think this is the picture that is after the PCR product that is run for more than 1.5 hours and all. Though this protocol is used both for quantification of the DNA as well as for PCR products. The only thing is the quantity of the agarose that we are going to use, concentration. That means if you are going to use 1% or less than 1%, then it is for DNA quantification, and if you are using for more than 3% or 2.5% or 3%, then it is well suited for your PCR products. So hope it is very much clear, and if you have any doubts, you are very free to reach me. Thank you.